My name is Chris Boden. I'm from Canada, I am the co-author of React from the previous talk, along with Igor Wiedler, which is event-driven asynchronous programming for PHP. And I'm the author of Ratchet, the PHP library for serving WebSockets. And this presentation is WebSockets. It is a slightly interactive demo, so if you want to follow along in Chrome at http://10.3.40.3, and you can follow along in the slides. Okay, so what are WebSockets? WebSockets are web technology providing full duplex communication channels over a single TCP connection. So WebSockets are mostly were created for and meant for, but not exclusively used by web browsers. But HTTP is stateless. So how does this work? It works like holding a door open. WebSockets are over HTTP, which is over TCP. I actually had a UDP joke for all of you guys, but you might not get it. Thank you. So remember, HTTP is a stateless protocol. Request, response, connection closed. So holding it open, holding a HTTP connection open with WebSockets is like holding a door open that has a lever and is meant to be closed. And what happens is the client and server agree and decide to speak a different protocol once this has happened. So, the stack. We took a stateful protocol, TCP, which is very reliable and was made back before I was born. And then we added HTTP on top of that because it was too hard to program for. And the computers weren't quite powerful enough to handle a large number of connections. So the HTTP protocol was invented in the web, and it was a document format. So you make a request, you get an HTTP response back, connection's closed, you render it. And now computers are very, very, very powerful. So we want consistent connections. So we took the TCP, the stateful protocol, added HTTP on top of that, the stateless protocol, and then decided we want stateful again. So on top of that stateless protocol, we're going to make a stateful protocol. What? So all that does is make the protocol open by not closing it. So how do you recognize a WebSocket request? Let's take a look. So this is the WebSocket request and response made to on this slideshow. So it is recognized by the server who supports it by its HTTP headers. And that requires a connection variable that says upgrade, an origin tag, which is meant for security. We'll touch on that later. Actually, I don't think that's required, but recommended. A WebSocket key, which is an algorithm that the server is to recognize. The keyword upgrade with the value WebSocket, and that is it. The server can choose to recognize this or not. If a server wants to speak WebSockets with you, it will take the key, do some kind of algorithm on it, which I forget exactly what it is now, something about hashing that. It's nothing for security. It's just to make sure that the client and server understand each other. And it will use that to give an acceptance token, which says to the client, yeah, OK, I am willing to speak WebSockets with you. Let's have a stateful connection. And then return the HTTP response, like a normal HTTP response. But the server, this time, does not close the connection. Any data after this is not to be HTTP. It is to be of the WebSocket protocol specification. So from my previous talk, it's all about protocols. Once this connection's opened, like a TCP socket, the client and server can send data to the other one at any given time, and that's all there is to it. It's like a telephone. But as I demonstrated in the last talk, sending data back and forth is useless. It's garble, it's gibberish. You can't understand it. And because of the nature of TCP, TCP is reliable, but the data stream may not be. You will always get what you put in. It will come out the other side. But what TCP does is it fragments and concatenates. So if you send a message that is 50 bytes long, there's no guarantee that 50 bytes is going to get sent at one time to the server, or from the server to the client, because it is bidirectional. Depending on latency, TCP will decide at any point, of all the hops through the routers from your client to the server, how it's going to chunk it. You might get it back in 3 chunk bytes, a 4, a 5, whatever, but you will get the message. And if you send a series of small messages, if you say, send hello, send world, send hello, send ski PHP, and you send them all at once, your browser, because it's allowed to with TCP, might jam them all together, and you will get one long string of all those. So how do we make sure that what you send in as a message comes out as a message? And so that is what the RFC 6455 protocol is about. I won't go into too many details about this, just know that WebSockets are message-based. TCP is stream-based. TCP, you will have a wide open connection, and with WebSockets, it will use that, but it will send in a protocol that is message-based. So what can this be used for? Possibilities are wide open. All you do is send data. It's a very simple concept. It was the React talk, but over the web browser. That's all this is. So here's an example of anyone who has this open. Anyone? Do you have this open? Are you following along? There you go. Thank you. So I'm taking all his data that is being relayed through the canvas, sending it to my server, and then broadcasting it out to everyone who is connected. And anything you draw will show up on anyone else who is connected to that. So this is one simple demo of how WebSockets can be used. Some other purposes are just pushing data real time. So whenever something happens, you can trigger an event to send data to the user. It's push oriented, you could say, as a marketing gimmick. Nice, I like the happy faces. So now introducing Ratchet. Ratchet does not have a logo, unfortunately. If you haven't been able to notice, I'm not artistically talented. Does anyone want to do a logo for me? This talk is mostly on Ratchet, which is the PHP library for WebSockets, but all the concepts and the principles are language agnostic. So you can do this on mostly any language that has a WebSocket library, which is almost any language. Ratchet is built on top of React. So it has all the benefits that come with React. And again, it's just the WebSocket protocol on top of TCP, which is what React handles. So Ratchet is WebSockets in PHP. It's PSR 1 and 0 compliant, but not 2. It's on packages, on GitHub, and it is unit tested, it is Autobahn tested, and it is integrated tested. So that should make Grumpy happy up there. Again, it's built on top of React, and it is RFC 6455 compliant, as well as HXC 76 compliant, which is an older version of the WebSocket protocol. So it is supported on a large number of devices. And it is architected, made of loosely coupled components, also known as maybe middlewares. So I talked about the protocol before, but the protocol is the underlying technology of it. As a developer, you'll be more concerned about the API, and that is how you interact with it. And the WebSocket API has 4 methods: onOpen, onMessage, onClose, and onError. And these methods are exactly the same on the client and the server. So they each share these because it is bidirectional. And once the connection's made, as I said before, anyone can use these methods to talk to the other one. And these events are, again, triggered on both. So Ratchet has a few interfaces, but the 2 primary interfaces that you would use most are component interface and connection interface. Actually, that should say message component interface. Copy, paste, fail. So onOpen, message, close, and error. Each of these are events that are triggered. So when you make something, your class would implement this interface. And a connection interface is passed, which is the bottom below. So like in React, and unlike most traditional PHP websites that are siloed into a single environment, one running Ratchet application will house many connections. They will talk to the same server, same service, and they share resources. So using global variables, which you shouldn't be doing nowadays, is very, I don't even say bad, but useless. So the connection interface has 2 methods, and this is the same on the client side, the JavaScript side, which is send, and send a message to the client, and close the connection. At any time, the server or the client can choose to end the connection. So here is a JavaScript example. We're using the WebSocket API. onOpen, we passed it a callback, say the connection was established, ask what your name was, send it, and when we receive a message, we console log the message to your console. And then when we close, we just say the connection is closed and curse when there's an error. So if you're following along, take this code from your web browser, copy and paste to here. And in your console, debug console, paste. Ask what your name is. And hey, Jeff's here. Who's Jeff? Thanks, Jeff. And now what you can do now that this connection's established is send messages. And now I'm talking to the server. The server has many connections it's housing, loops through each of these connections when it receives a message, and sends it out to everyone else connected. Jeff, want to send me a message? And Curtis connected. Okay. So so that's a simple example of a basic chat, I guess you could say, in using WebSockets. Ratchet is installed via Composer. Has everyone used Composer before? Not as many hands as I hoped. Composer is a dependency management application for PHP. It is fantastic. I can't say enough good things about it. So that chat info we just, the chat I just demoed, this is the source code to it. It's pretty simple. We implement the message component interface that I showed a few slides ago. On a construct, we create a new SPL object storage, which is a container that you can put objects into. You could use arrays to store connections, but arrays are very resource intensive. They're kind of a jack of all trades in PHP. They're very powerful, very good, but in this scenario, it'd be like killing a fly with a sledgehammer. So we use SPL object storage, which better handles is better on memory consumption. And this is a long-running process with many connections connected to it. So managing resources is actually important now. If you want the script to be running over days, months, weeks, wrong order there, you need to make sure you free your resources and try to consume as little as possible. So we have our 4 methods: open, message, close, error. When a connection is opened, we throw it into our cons object. Just so we're storing a reference to all of our connections. When a message is sent, we loop through everyone who is connected and send the incoming message to the person who, to everyone else other than the person who sent it. And when the connection closes, via client or the server, we remove the reference to it. And that's handling our resources. And PHP garbage collection will take care of the rest. So execution. I just want to ask, has anyone tried Ratchet before? 3? Cool. Anyone used 0.3 of those 3? Yeah, I didn't think so. So this is a new API. I got a lot of complaints about the old one of how to use it, in that it feels too much like Java. So after you create your class, and this is the logic, you have to create an executable script. And so to do that, you create a Ratchet app, give it the host name, the port number you want to bind it to. All these parameters are, the first one's not optional, the rest are optional. What interface you want to bind it to, and from the last talk, 0000 means any machine connecting to your computer will have access to it. But if you bind it to 127.0.0.1, that means only your machine can access it. And the 4th optional parameter is a React event loop. If you do not pass that, it will create one itself. And you add a route, so /chat to this. And then you run, and you enter a React event loop, and just wait for connections and messages to happen. And just go back. Right, so here, when we connect to /chat, that's the route we're connecting to. So you can add multiple applications to one running server, accessed by different URL endpoints when you're making a WebSocket connection from your client. So how does Ratchet work internally? How does app work? And this is what you used to have to compose yourself. Ratchet works by using the decorator pattern, which is an object-oriented design pattern. It starts with an I/O component, which is bindings to React's I/O. After that is an HTTP layer, because it has to handle all incoming HTTP requests for that connection upgrade process I showed earlier. Then we have a router, which can host different apps based on the URL you take. So /chat was the one we just showed. WebSocket handles the protocol communication. So that was the RFC 6455 we demoed. Any other middlewares you want to put in between. And finally, your app. And I just want to go back and give a quick demo of the app.source. I don't expect everyone to look through all the source code to use this. I just expect most people who would to use the API, and that's this. But I do think it's a little important to see how app works. That's a facade class that kind of does all these things here for you. So this is the source code to app. As we show in the construct, it takes the host name, which is very important. I'll get to that in a bit. The port you want to bind it to, the address, and then the loop interface. And by default, it is set to 127001, and this is for security purposes. And I'll cover that in a short bit. After that, we create a React socket. This was aliased socket server. We bind it to the port and the address given. We create a new route collection, and Ratchet has a dependency of Symfony routing. So rather than do all this ourselves with Knee, we use Pi, proudly invented elsewhere. So using Symfony routes is very nice because it's tested, used by thousands and thousands of developers, and I can just throw it in. Then we create a I/O server, which wraps an HTTP server, which wraps the router, which wraps a URL matcher, which is part of Symfony routing. We create a request context. And again, that is doing this for you, wrapping the I/O, the HTTP to the router. After that, we add a flash policy, which I will cover in a bit. We also create a new I/O server and bind that to React as well. And then we have the route function, which you can add any number of applications to your running WebSocket server with. So you add the path, in our example, /chat, and you add a component interface. So I showed you the message component interface, but it's actually an extension of the component interface, and I'll cover that in a moment. Allowed origins, this is a security feature, which I'll cover in a moment. And then we wrap it in a WebSocket interface if it's not already, so to handle the WebSocket requests. And then we create an origin check class, wrap it in that, and then we finally add it to the Symfony route. And so the origin check is one of these middlewares I talked about. You can, the design principle says favor composition over inheritance. So we've created several small different components that we can use together in any order to create different functionality. And I just want to touch on the origin check for a moment. So what this one does, and this is kind of why app.php exists, was because this is a lot of boilerplate code that people used to have to write. So this is an opinionated facade. Has anyone used stack.php before? Anyone heard of stack.php? 2, 4, 5 people? Okay. So this kind of takes that philosophy. Okay. So I wanted to point out this HTTP header, and this is what origin check does. When you make a connection to a server, WebSockets are not bound to the same limitations that AJAX are by security. You can be on any website and open a WebSocket connection to any other website, and that is allowed. When you make AJAX requests, the browsers strictly prohibit this. And you have to do a lot of work to maintain security and prevent CSRF attacks and XSS attacks. So what the WebSocket protocol does to handle security is passes an origin. So any site can connect to another website, and you might not want that. So what it does is it passes an origin. It says, I am connecting from this server, and it lets the WebSocket server know where you were coming from. So what this does, and Ratchet app does by default, is adds an origin check to every route you add, every route you create. And what this does by default is your host name here. It will only accept origins from that same host name. So if someone tries to connect to your website and they're not coming from the same domain as your website, it will block them. And this is some security that's added by default. And again, that's one of these middlewares here, just added. Okay, so all the components that are currently in Ratchet, which you can piece together using this decorator pattern, that all implement the component interface. I/O server, which is binding to React to handle I/O. We have a flash policy, which I'll cover in a bit. Echo server was just a quick example. Anytime you make a connection, send a message, it sends it back to you. That's actually used for one of the Autobahn testing suite. IP blacklist, if someone's harassing you or your website, you get their IP address, you can add to this. It'll immediately disconnect them when they connect. HTTP server handles the HTTP requests. Ratchet actually can be used as a full-fledged HTTP server. I don't recommend you do that. It's not good at it, but you can do it because WebSockets are just on top of the HTTP protocol. Origin check, which I just showed, is a security feature. Router allows you to use different components or create different endpoints. Sorry. Session provider uses the who uses Symfony or has used Symfony? Good number of people. So Ratchet uses the HTTP foundation, and it has access to Symfony sessions. So if you use Symfony framework or components and use their one of their session handlers, and what that does is lets you use Redis or Memcache or several other session providers with the same API. Ratchet can use that same code if you configure it and access their sessions, your same user sessions, because cookies are passed on the HTTP request. WebSocket server handles the protocol, and WAMP server, which I'll cover in a moment. So the chat demo was nice, but it's what I've been saying with the React one. It's all about protocols. That, after you add the WebSocket protocol, you're just sending raw messages back and forth. It's not very useful or practical, and it's just kind of raw. It was like the first telnet demo we gave, or I gave. So WAMP is not what you think it is. It was created, it is a protocol, text-based protocol written in JSON, created by a fellow who wrote the Python WebSocket library, and who never used PHP, so did not know that WAMP was an acronym for Windows, Apache, MySQL, and PHP. It stands for the WebSocket Application Messaging Protocol. JSON human readable. It implements the pub sub and RPC messaging patterns. It is a middleware included in Ratchet, and it has an official JavaScript library for the client side, which is called Autobahn.js. Anyone else lose Wi-Fi? Okay. So if you're following along, you got to push the arrows right now. My remote just died. So events for the WAMP are welcome. So when a connection is made, the server will send a welcome message to the client, and this includes things like a session ID, protocol version, and that kind of stuff. Prefix is going to be deprecated, but it's like an alias. Call. Client to server can make an RPC call, which stands for remote procedure call. And that will say, I want to do something. And at some point in time, the server will send back a result or an error. And this is used using a promise API. The client can then also subscribe, which subscribing to channels, can unsubscribe, can publish to channels, and also has an event on the channels, which is when something happens. Oh my. Sorry, one moment. Anyone have questions while I'm fixing my remote? Anyone? Okay, so let's talk about the pub sub pattern. Subscribe, unsubscribe, publish, and event. Pub sub stands for publish and subscribe. And when you have one WebSocket connection that is like a pipe, you can subscribe to what are called topics. Other paradigms are also known as channels, or I forget the other term. But in WAMP, they're referred to as topics. And a topic is like segregating content inside the pipe. So it's almost like multiplexing. You can have isolated communication from each channel inside the WebSocket. So anything that is published on one topic, anyone who is subscribed to the topic will receive the message. And clients can publish to a topic. The server is like a broker. It can decide what to do with that message, and then it will reroute that message to everyone else in the topics by default. But the behavior is actually controlled by your code. RPC is like a promise from React. It uses the promise API, so it will make a call to the server. The server will choose if and when to handle the request and send back a response or an error. Can anyone tell me what slide this is? Any number? 21? Awesome. Thank you. Okay, perfect. How am I doing on time? So the WAMP interface extends the message component interface. So here are all the methods you have on the server side. So onPublish is when a connection sends a message to the server, and you can choose to route that or broadcast it to the rest of the connected clients. Open, close, same as before. Unsubscribe is when a connection subscribes to a topic, and on an error. And there is an implementation of WAMP interface in Ratchet that handles all this by default, because the basic pub-sub pattern is when you subscribe to a channel, you get all updates, and when someone pushes that channel, everyone connected will receive it. But for your application, you might not want that. For example, this is running on WAMP right now. I have a remote control written in that uses the WAMP client, and only it's allowed to publish to the remote control channel. My server has specific code that will reject anyone else trying to publish to the remote control. Okay, now the Autobahn code is the JavaScript client-side implementation of the WAMP interface protocol. So I lost a bit of time. So this is a demo. If you want to copy and paste that code and have a couple chats with each other in a session management, go for it. I'm going to skip the demo though. Stomp is another text-based protocol that is used good option for communicating over WebSockets. It's text-based, very human-readable. It's not supported by Ratchet yet. If anyone wants to volunteer to write it, that'd be awesome. It's implemented in React and has pub/subs, transactions, wire meta. It's very verbose. So support. WebSockets are supported in Chrome 4, Firefox 6, all these. And as of Internet Explorer 10. Awesome. So this is, yeah. So WebSocket Gotchas. Not everything's perfect. There's some issues you have to be concerned about when writing for this. So the first one is supporting older browsers if you have to. Supporting 7, 8, 9, we'll cover that. iOS 4 to 6 buffers terribly because they're allowed to. It is the TCP protocol that says, I will send you a message and I will choose when to send it to you. You will eventually get it. And Apple always thinks they're smarter than their users. So Apple usually chose to not send a message until it reached a certain length or a certain amount of time. So when I gave this presentation, the first time I gave it, my remote was on iOS 6, and it would work for a little while, and then when I didn't touch it, the WebSocket hadn't closed, but 30 seconds later, it was like, I'm going to sleep now. And I'll decide when to send your message to move the slide. So that was nice. Beware aggressive proxies. 2014 is less of an issue now, I think, but some proxies will discriminate against WebSocket connections. Usually it's not intentionally. Usually it is because they're old and dumb. They're like, upgrade, that's not a HTTP header, and take it out and forward it on to the server, which doesn't have the upgrade header and doesn't know to speak to the WebSockets now, speak in the WebSocket protocol. Horizontally scaling is much harder than a synchronous stack. If you've ever written a large site that has a huge amount of traffic, you'll probably have load balancers which talk to several servers which are the same. They will handle the response, talk to the same database, have caching, but send it back. So every request coming in may come in to a different server and handled and sent back, which is okay because HTTP is stateless. When it's stateful, this is an issue. This demo, if we were to send to 2 different servers, being a stateful connection, if my remote's on server 1 and the presentation's on server 2, it's just not going to work. So you need to have something in there that will let them communicate to each other without also becoming a load on itself. Message brokers are a good way of doing this, and clustering. Race conditions will happen. This is asynchronous code, which means I/O will happen when it happens. It is outside of your control, and you have to use defensive coding style to make sure that your script doesn't crash. And again, one process to bring them all together, one error to ruin them all. If you go to a website and you have a PHP seg fault, that one user who went to that site who caused the fault gets a 500 error. If you have a running script, and this is in any language, and one user does something that makes it crash, everyone crashes. Everyone's disconnected. That's the end of it. So again, defensive coding is very important. Supporting browsers. That Flash policy file in Ratchet by default will support Flash. Flash has its pros and cons of supporting WebSockets. It is very easy to implement. It is already natively supported in Ratchet. All you have to do is on your client, JavaScript side, include 2 files, and you're done. It is a true polyfill. It speaks the WebSocket protocol through Flash sockets. They're IE users anyway. And I don't mean this is such a bad thing. If a user is using 7, 8, or 9, Flash still has a very high penetration rate. Odds are they have Flash installed. The cons, it's Flash. Flash sucks. It takes up to 3 seconds to connect. So if a proxy is blocking Flash WebSockets or it's just slow, it's another request and it takes time. The way the Flash policy works is the server says, oh, I have Flash. And then Flash has this great security policy where it talks to the server and says, on a special port, and says, can I talk to your server on the port you originally wanted me to talk to? And it sends back an XML file saying, yes, you can. And then it makes the request to your WebSocket servers through Flash. Sometimes this custom port is blocked by proxies. It's on port 843, if I remember correctly. 843. So some proxies will block that. So you have to be aware of your clients. Other ways to support IE 7, 8, and 9, and anything else that doesn't support WebSockets, like older versions of Android. We have two other things, methods of doing this. HTTP fallbacks. So before WebSockets, to do anything that seemed kind of real time, you would use long polling or a technique called Comet, which would hold and open an HTTP request and send back messages when it was ready to. There are 2 protocols that kind of wrap the WebSocket protocol and handle this for you. One's called Socket.io. Has anyone heard of that before? Most people have. It's very popular. It was the first to the market. By their own admission, it was a bad design pattern. Socket.io is a monolithic thing. It has its own protocol for handling messages. It's not raw WebSockets. It also has fallbacks, which is nice. So, actually, sorry, it doesn't have fallbacks. It's the opposite. It will make an HTTP request connection using a Comet or an AJAX style, and then it will make a WebSocket connection and close the other one. So this is making 2 requests, which is incredibly unnecessary, which almost kind of defeats the purpose of WebSockets. WebSockets are very light. Once the connection's open, you send 2 bytes plus your message. If you're doing Comet, every user is isolated into their own instance again. But every request and response, even though it seems real time, you are sending HTTP headers, a large amount, which will usually be larger than your message. and it's very wasteful. The other way to supplement the older versions of IE and those who don't support WebSockets is something called sock.js. I think it's a much better design pattern than sock.io, but it came later, so it's less popular. What it does is it tries to make a WebSocket connection, and if it doesn't, then it falls back to the other connections. And it's so seamless. And it wraps the WebSocket API very natively. So you just say new sock.js as if it was a WebSocket. And they're future-proof. So the author, the guy who created sock.js says, my hope one day is that this project will die, which is fantastic. Because once WebSockets are implemented everywhere, you just won't need sock.js. You will take it out, and your whole application will still just work the way it was before. It is a very nice polyfill. Reverse proxying. React and Ratchet will never support SSL for server. We do support it for client because if you're making a client connection, you need to talk SSL. But if you're writing a server, PHP is kind of slow and SSL is slow. And if you go back to my first presentation, it's all about the Unix philosophy of making small components. We highly recommend if you want SSL and recommend using SSL, you put your script behind a reverse proxy that will handle SSL for you. So every incoming connection to your website will hit Nginx, HA proxy, or stunnel, do the SSL, and then on the same machine, talk to your WebSocket server. And I recommend this for any language you write WebSockets in, whether it's PHP, Ratchet, or Node, Python, anything else. In Apache, I won't get too far into it, but I don't think Apache will ever properly support WebSockets because of the way it was written. But that's my opinion. Don't take that as fact. Inter-process communication. There's many ways of doing this. Ratchet or React by default supports 0MQ. Has anyone heard or used this before? Excellent, nice, good number of people. So I could do a whole talk on this, but I just like saying 0MQ is TCP on steroids. It handles concurrency for you. It handles messaging for you. Like I said before, TCP is a stream. 0MQ is a message-based protocol. It does a lot of messaging patterns, and it's asynchronous I/O. It handles threading for you. It does a lot of good things. It is written, I think it's written in C++. Anyone want to correct me? Yeah. Okay. So I think it is written in C++. Doesn't matter, and it has bindings for 20 different languages that use the same original library. So the C PHP extension is written in C, but it talks to the same shared library that works on all languages. So there's no fragmentation across it. And 0MQ is very good for talking with other processes that you trust. So a pattern to use is binding a 0MQ socket to React in the event loop. If you remember from my last presentation, you can bind multiple servers to one event loop and handle it. So if this server code on the bottom, there's a bit of code missing, you have to fill in the blanks. But if we create a Ratchet app and pass it an event loop, and then we create a new 0MQ socket and bind it to the same event loop, and then we say, when we receive a message from 0MQ, forward it to the Ratchet application. And then that Ratchet application could handle that message and then would probably send it out to other users on the web on their web browsers. It's routing messaging. And so the client is pretty simple. You make a 0MQ context, and this is an extension. It's documented on php.net. You bind it to an address and a port, and you send the post message. You should probably do some filtering and cleaning up. You should not send raw messages around. Never trust the user, all that stuff. So here at the bottom, we're binding 127.0.0.1 on port 555. So this means that only the server itself can talk through the 0MQ. If you were to try to talk to, on your laptop, try to talk to my machine on this port, it would be disallowed. My machine is only allowed to talk to my machine on this port. And so this is a security feature. this is a way of integrating WebSockets into your existing application without rewriting it. Because WebSockets are a very different paradigm. It's an asynchronous server. You have a whole different stack than your synchronous one. So something you can do is, without impacting your code, and you're handling messages before you write something in the database, say, I want to send this all to users connected, like a notification saying, someone just posted this. So after you insert the database, you take this client code, and you take the post, and you pass it off to the other running process. The other running process handles this and pushes it to the WebSocket on your client. And then you can update the, send some kind of visual notification in the user's web browser. And this is a very good pattern without disrupting what you already have in an application if you can't start over rewriting your architecture. Haters gonna hate. This is PHP and WebSockets and evented programming. PHP was not meant for this, or so I'm told. PHP was never meant to be an object-oriented language back in PHP 2 or 3. PHP today has a lot of things that it was never initially designed to do. And I admit that this is a little awkward, and I'd like to hope that we're pushing the envelope with this. And that, yeah, someday PHP will be recognized that, yeah, it can handle async and I/O, no problem. It is not bad now. It's not as bad as people told me it would be. I haven't fully load tested this yet. That's something on my to-do list I'll get around to, but people who have used it, I've had them post on the forum saying, my site got hit Hacker News, and I got 5,000 concurrent connections, and the application didn't crash, and it served everyone. It was fantastic. That being said, I don't think PHP right now would live up to other languages as far as concurrency goes. 5,000 is good. I do want to push the limit and see what it can get to, but PHP is a little slower than other languages, and I think this is going to, with the more event loops coming in the C library, I think this is going to help execution speed. Opcode caching in 5.5 for a long-running process, I think is going to be a big deal. And I think HHVM could be a big deal for this. So when should you use PHP for WebSockets and when shouldn't you? Right tool for the right job. If you're doing a small to medium-sized site and 5,000 concurrent connections is how many you're going to have, go for it. If your primary language is PHP, it's very easy to write, and you have one language. If you are not already in a polyglot environment, adding another language is taking on technical debt because you have to train everyone who comes on this other language that you've written that is different than your entire stack. So if you are going to talk to other languages, here are some of the implementations in each of those languages. So Python has Audubon Python. Oh, and one other thing about PHP not being synchronous and not being meant for evented programming. Guess what? Neither was Python or Ruby. Those two were both like PHP, and they were originally synchronous, and they did what we are doing now, and then they wrote asynchronous protocols for their applications. Node is very popular right now. It is asynchronous by default. It is not a synchronous language. And it's kind of easy to get going with, and that's why it's very popular right now. Erlang has Cowboy, and Go has Gorilla. And Erlang and Go are both meant for concurrency from the get-go. That was their fundamental design when the language was created. If you're going to speak with these, so if you have your PHP website and you have a website and you have such high traffic that PHP isn't going to cut the WebSocket part of it, how do you talk to them? It's all about the protocols. So you can use ZeroMQ, like the example I showed before. You can use ZeroMQ to make a distributed message broker as well. It's quite a bit of work, but it's a very good option. Dnode is a protocol for a JSON protocol for communicating with a WebSocket server that also speaks Dnode. And RabbitMQ is a message broker, which is I call it a canned solution. It has its own protocol. It is a message broker. it's very good at distributing work. As well, if you want to use just WebSockets, there's a service available called Pusher, which has an HTTP API, which you can send events to, and then you put their script on your web page, and they will receive those WebSocket events that you pushed. Most importantly, when you're developing this in any language, race conditions. You need to take care of them and use defensive programming. Be like this dog. Be very careful. So this PHP error at the bottom was when I first released Ratchet. The demo on the website is an IRC-like chat room. You can join channels. It has presence, shows who's online. You can send messages to each of the channels, and this is using WAMP in their topics. And it would crash every couple weeks when a lot of people came to it because, first of all, it was a lot slower back then. I've done quite a bit of optimization since. As far as speed, I/O speed goes, PHP is on par with the other languages I've seen testing with the Audubon suite. It's when you get to a whole large number of connections that I think PHP starts to falter compared to other languages, like over 10,000. Again, I don't have exact numbers. This is something I need to do. Anyway, script crashed because PHP's garbage collector was faster than the I/O for me to remove one of my resources. React removed the socket, and I had tried to detach it, which was quite a while later, and garbage collection had already removed it, and the app crashed. That's since been fixed. Future, HHVM. I'm kind of excited by it and what it could possibly do. We want to add async session management, which is kind of already in progress. I said it handles sessions, but it handles them synchronously, which is bad when you put it inside an asynchronous application. Socket.io and or sock.js support. I would like to do sock.js support, and someone has already started writing sock.io support for Ratchet, and that is the fallback and the protocol, and binary message support. The components in Ratchet already support it, just there's no API for it yet because I can't decide how I want to do the API. Naming things is hard. That's my talk. Please rate it on Joined In. I appreciate any feedback. Does anyone have any questions? Yep. All right. If you have any questions, come see me. Thank you.